So you could also be given the pH or the pOH and then asked to calculate the hydroxide or hydronium concentration. In order to do this, what we do is the concentration of hydronium is 10 to the power of the negative pH. It is very important that you put negative pH in there. And the concentration of hydroxide is 10 to the negative pOH, okay? So if we try these, we should get easily the following answers. Okay, and it's a simple calculation in our calculators. Now, we need to be sure that we are using the proper significant figures. So, if I have two significant figures behind the decimal point on my pH or my pOH, that means that I have two significant figures in my concentration. Okay? Now, if we complete the following table, when we are given the hydroxide or the hydronium concentration, we are going to first calculate the pH, then calculate the pOH, then use that pOH to calculate our hydroxide concentration. Okay? And then given the low pH, we know this is an acid. Okay? If we are given the pH, then we can calculate the hydronium concentration. We can also use the pH to figure out the pOH, which then we can use that to figure out the hydroxide concentration. And given the high pH, we know this is a base. Okay? If we are given the hydroxide concentration, we can figure out the pOH. Use the 14 minus the pOH to give me the pH, which I can then use to calculate the amount of hydronium I have. And I would know, based on the low pH, that this is an acid. Okay? If I know the concentration, again, of hydronium, I can use that to figure out my pH. I got my pOH. Okay? So I'm just going to fill all of the rest of these in. Feel free to pause the video and make the rest of your notes. Okay? Now, determining pH. pH can be measured using acid and base indicators or pH meters. So, an acid and base indicator is any chemical that changes color in an acidic or basic solution. They can be dried onto strips of paper. So, for example, we've got litmus paper and pH paper. Okay? They can also be solutions. Okay? So, for example, bromothional blue, a universal indicator, and indigo carmine, etc. Okay? And they can also be made from natural substances. So, example, tea, red cabbage juice, and grape juice. Each indicator has a specific pH range where it will change color. And you can use two or more indicators to approximate the pH of a solution. Okay? pH meters, though, using a pH meter is the most precise way to measure our pH. It has inside of it an electrode that compares the hydroxide concentration of an aqueous solution to a standard that it will give a digital readout. Okay? Now, if we're going to dilute an acid or base, when we add water to an acid or a base, we change the concentration of hydronium or the concentration of hydroxide. Diluting an acid will decrease the hydronium concentration until a pH of 7 is reached. But diluting a base will decrease the concentration of hydroxide until the pH of a 7 is reached. Alright? So we need to remember that the C1V1 equals concentration final and volume final. Okay? And here are some examples that you guys should have. And we have some formulas to remember. Be sure that you are looking at the fact that these are negative, and we've got OH and pOH, okay? And you've got a review assignment there in your textbook as well if you need any additional questions.